Okay, good morning. This is Professor David J. Delos Okay, it's April 6, 2023. It's good morning already. The time is 2:49 here in Los Angeles, USA. My topic for this morning will be the climax of the topic under advanced mathematics, and this will now be example problems on how to take the Laplace transform of a given equation. Okay, so the topic for tonight will be example problems on how to take the Laplace transform. This is not related to any circuit problem or what. We are just given a function of s, and the problem is asking what will be the function, what will be that given equation as a function of time. Okay, let's proceed for this morning. I will check my camera. Oh, it's fine. My lesson for this morning, April 6, 2023, will be Advanced Mathematics lesson. This is now lesson number 28. So actually, we are moving gradually upward, okay? We are following our syllabus under the so-called Advanced Mathematics topic. The topic for tonight will be Advanced Math, lesson number 28, Laplace transform examples, meaning the evaluation of problems in transforming to Laplace transform. Okay, I will give you problem number 1 because we expedite a little bit because I will be giving 2 problems for this morning. Okay. Problem number 1. Function of s, small letter f, equal to s plus 12 all over s squared plus 4s. For Laplace transformation, the right hand side is actually as a function of s, okay, instead of as a function of t. And the left hand side is actually as a function of s. And the problem is asking what will be function of time equal to. We are given the function of s, and the problem is asking for a function of time. Okay, let's proceed with the solution. This is the solution. The solution is something like this. We will start with s squared plus 4s. Take note of the denominator. The denominator is actually a quadratic equation. And the purpose of taking the denominator is that we will take the so-called linear factors if it is factorable by inspection, okay? So the given denominator s squared plus 4s can be written as the product of s times the quantity s plus 4. Because s times s is actually s squared, and 4 times s is actually 4s. So meaning the quadratic equation s squared plus 4s can be written as the product of s times the quantity s plus 4. And by using our knowledge of the so-called partial fraction, if we are given 2 linear factors, those 2 linear factors can be written as a sum of 2 partial fractions. So continuing with the solution, okay, I will follow the given right hand side. S plus 12 all over, that is actually s squared plus 4s, and it can be written as the product of s times s plus 4. And this should be equal to, as I have said a while ago, if the linear factors are 2, the corresponding equivalent partial fraction should only be 2, should also be 2. So it can be written as a over s, okay, plus another constant b, unknown constant b, all over s plus 4. Okay, this is the first linear factor. This is actually s minus 0, or simply s. And the second linear factor is actually s plus 4. So under this s here, there is an unknown constant a, and under this s plus 4 here, there is an unknown constant b. And to bring out the solution of the Laplace transform, we will compute for the value of a and b using our knowledge of algebra. Okay? So combining the resulting equation, it will now become s plus 12 should be equal to A times S plus 4 plus B multiplied by S. Okay, this is now the so-called, according to Mr. B, we use the so-called butterfly method. That's why we use the butterfly method here. We take the product of this, it is this. Then we take the product of this, it is this. Okay? All over the common denominator will be the product, right? So this is actually S times S plus 4. Okay? And the left hand side, this is still S multiplied by S plus 4. Okay? This S here cancel with this, and this S plus 4 here cancel with this. Or what will come out, it will just be simply the, after multiplying the butterfly method here, actually the denominator vanishes. So actually this is gone. I will erase it. Okay? But to show you that it vanishes, it is just simply like that. We will rewrite the denominator. So we could cancel out. Right? This is S plus 12. So there's a use of the so-called butterfly method here. It's just a method of combining two fractions with different denominator. You cross multiply this, you add this, and the resulting denominator will be the product. And the product is the same as this. So actually, this cancels out. Right? Or it will just be simply S plus 12 equal to A times the quantity S plus 4 plus BS. And to compute for the value of A and B, we will equate coefficient of like terms. We will start with S to the first power. Left hand side, the coefficient will be 1. Right hand side, the coefficient will be A. Okay? And the other coefficient is actually B. Because ES, the power is 1. BS, the power of 1 of S. And this here is S to the 1. That's why I place it here. S to the first power for both the left and right, we will equate the coefficients. So 1 will be equal to A plus B. We call it equation number 1. Let's go with S to the 0. S to the 0 meaning all pure constant terms for both the left and right, we will equate. For the left hand side, the pure constant is 12. So this is 12. And the right hand side, the pure constant is actually any term without an S. That will be 8 times 4 is 4A. That's it. So meaning 12 is equal to 4A. So A now will be 12 over 4 or A will be equal to 3. So we now know the value of A. And by using equation number 1, 1 will be equal to 3. We are following equation number 1. 3 plus B. Therefore B now will be 1 minus 3 after a transposition. B is actually equal to negative 2. Oh, it's just pure algebra. I will check my camera. Okay? So, going back to the given function of S, small letter f as a function of S. Small letter f as a function of S should be equal to A over S plus B over S plus 4. This should be equal to A is actually 3. Right? Over S. Plus, open quantity. I put the quantity here because there is a sign for the value of B. Open quantity, the value of B is actually negative 2 all over S plus 4. This is very dangerous because there is a negative sign here. I put the quantity. So function of S now will be 3 over S. A plus and a minus will be minus over, this is multiplied by 2 all over S plus 4. Okay? A plus and a minus is a minus. So the overall sign here will now be minus. Take the inverse Laplace transform of both the left and right. The inverse Laplace transform of function of S, this is Laplace transform, right? If I put a negative 1 here, meaning inverse Laplace. Okay? So the inverse Laplace transform is small letter f as a function of S should be equal to the inverse Laplace transform of the first term. 3 over s minus the inverse Laplace of the second term, which is 2 all over s plus 4. Just like in the integration and differentiation, all pure constant term, we bring it out. Okay? So this can be written as 3, the inverse Laplace of 1 over s, minus 2, I bring it out, 2, the inverse Laplace of 1 over s plus 4. The inverse Laplace transform of small letter f as a function of s is what we are looking for. Small letter f as a function of t. This should be equal to 3. The inverse Laplace of 1 over s is 1. Try to verify your table, the one we have derived. And the inverse Laplace of 1 over s plus 4 is actually a raised to minus 40. 1, the inverse Laplace of 1 over s plus a is actually a raised to minus 80. Right? So this is negative. Right? So our final answer now, small letter f as a function of t should be equal to 3 minus 2 a raised to minus 40. Our final answer. Okay? So that's the importance of the table we have derived. The Laplace transform of 1 over s is actually 1. So if you try to take the inverse Laplace of this, okay, the inverse Laplace of 1 over s, what will come out will be 1. So I place this as 1. So our final answer is actually 3 minus 2 a raised to minus 40. Our answer. That's problem number 1. Okay? It seems we are integrating. So the rule, if there is a constant inside, we bring it out before we will take the inverse Laplace transform or the so-called Laplace. Okay, let's proceed with problem number 2. Small letter f as a function of s. Okay, I will try to erase this one so it will look nice. Okay. Problem number 2. Small letter f as a function of s is equal to 3s over s squared plus 2s minus 8. The problem is asking for small letter f as a function of time equal to solution. As always, we try to simplify the given denominator. The given denominator is again what you call this quadratic equation. S squared plus 2s minus 8. So use your knowledge of algebra here. The possible factors of s squared is s and s. And the possible factors of 8 is 4 and 2. Let's try to check the value of the middle term. This is 2s and this is 4s. The product of 2 times 4 is 8. But the sign should be negative. Okay? So this should be plus and a minus. Okay? So minus 2s plus 4s. So the value of the middle term is actually minus 2s plus 4s is 2s. So the possible factors of this by inspection is actually s minus 2 times the product of quantity s plus 4. Okay? That's pure algebra. That's why I told you the manipulation should be algebraically. Okay? So rewriting the given small letter f as a function of s, we are still not taking the Laplace. We are just evaluating the value of a and b, because since there are two linear factors, there should be two unknown constants a and b again. So following this, 3s over s squared plus 2s minus 8 should be equal to, there are two linear factors, so there are two unknown constants a and b, so it should be a all over the first linear factor plus b all over the second linear factor. Okay? Again, using the rule of Mr. Bean, you cross multiply this one, right? It is this. We'll go with this first. A times s plus 4 will be this. The product of b times s minus 2 is the second one. All over the common denominator. The common denominator is actually s minus 2 times s plus 4. Okay? For the left-hand side, the denominator is again s minus 2 times s plus 4. So actually, this cancels, or it seems the denominator is gone, right? So what will come out will just be simply 3s equal to, we try to expand a little bit. Es, this is 4a plus bs minus 2b. So this is now the required equation, and where we will bring out the two linear equations to solve for the unknown constants of a and b. Okay, equating coefficient of like terms as before. Okay, we will start with s to the first power. For the left-hand side, the coefficient of s to the first power is 3. This is s to the first power, this is to the first power, this is to the first power. So for the left-hand side, the coefficient of s to the first power is 3. Right-hand side will be a plus b, equation number 1. Next one, s to the 0 power, meaning all constants for both the left and right. Okay? There is no constant on the left-hand side, so we place it at 0. For the right-hand side, it will be 4a, okay, minus 2b, And simplifying this one, b now will be equal to 2a. So solving simultaneously equation number 1 and number 2, if you try to solve this one by yourself, a will be 1 and b is equal to 2. Right? That's pure algebra. Therefore, going back to the given function of s now will be 1 over s minus 2. Okay? We are following this. A is 1 over s minus 2 plus the value of b, which is 2 all over s plus 4. Okay? Take now the inverse Laplace transform of both the left and right. The inverse Laplace transform of small letter f as a function of s should be equal to the inverse Laplace of 1 over s minus 2 plus the inverse Laplace of 2 over s plus 4. The inverse Laplace of small letter f as a function of s is what we are looking for. Small letter f as a function of time should be equal to 1 over s minus a is actually e raised to at. And 1 over s plus a is actually e raised to minus at. Okay, so if you try to take the inverse Laplace of this to the minus 1, the inverse Laplace of this to the minus 1, we will follow this. Right? So it will now be equal to 1 times the inverse Laplace of s minus 2, we will follow this. The exponent should be plus, right? This is minus, the exponent is plus. E raised to 2t plus. We bring out 2, and the inverse Laplace of 1 over s plus 4 is actually, if this is plus, the sign of the exponent is minus. So this will be 2e raised to minus 40. So our final answer will be small letter f as a function of time. What we are looking for will be e raised to 2t plus 2e raised to minus 40. That's our final answer. Okay? It is simple. It is simple because, what do you call this? We derive first the formulas for Laplace transform and inverse Laplace transform. So it's just a matter of recalling when we are solving the problem. Okay, that's it, guys. So for those persons who are taking advanced mathematics, this is for you guys, okay? If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. Good morning from Los Angeles.